Okay. Welcome, everyone. My name is Sophie Bramel. I work for World Sports Activewear. And in the January issue of the magazine, I did an article on ocean-bound versus ocean-found plastics. And I thought it would be a good idea to bring together companies that are working in that field. So we're not exactly beyond the bottle. There are still bottles being recycled into polyester yarns, and that need to be, well, we need to find some sort of use for these, especially those that are abandoned on the tropical beaches that we all love, and those that are in the ocean already. So I have with me David Bayliss from Advansa, who will be telling us about ocean-bound plastics. François Devy, right next to me, from the Seaqual initiative, doing some very interesting stuff to keep our oceans clean. And David Kwon from Hyosung, who is probably a pioneer in this field. Company has been recycling fishing nets for a long time. Thank you for coming here. And to begin, can I ask you each to introduce yourselves a little bit more in detail than I did, and the companies you work for, and then we'll start with the questions. So who wants to start? François?
Yes, nice to meet you all. My name is François, MD from Seaqual Initiative. So our mission was born in 2016, and our mission is really to remove the plastic, the degraded plastic, out of the ocean, as you can see here from the video, and turn it, before it turns into microplastic, into a new yarn. And we are vertically integrated from the collection to the recycling to the spinning, with factories in Europe and Latin America.
Thank you. David, do you want to?
Yeah, good afternoon. My name is David Bayliss. I'm Managing Director at Advansa. Advansa is a European polyester supplier. Was formerly the DuPont polyester business in Europe. And we've been recycling plastic bottles in Germany into polyester fiber for the last 10 or 15 years. And the last 4 or 5 years, we've also added to our range what we call ocean-bound plastics. I think we have an opportunity to explain what that means later on. And you also see here on the chart APF, Asia Pacific Fibers. We're affiliated since 2020 with APF, and we've developed with them together a range of products for the apparel industry. Only from Germany, we were selling into the home textiles industry and now into the apparel industry. And because we're talking about apparel, we added a biodegradable additive, what we've just heard about, really, that if we want to avoid microplastics shedding into the ocean, it will be better if they biodegrade at a slower or faster rate, apparently, but nevertheless not hundreds of years.
Thank you. David?
Hello, my name is David.
Let me move on to Hyosung.
Yeah, my name is David Kwon. I come from a company called Hyosung. We produce all kinds of synthetic fibers, including polyester, polyamide, and also spandex. Our brand name is Creora. I assume that many of you heard of it already. And sustainability and recycling is the biggest business of our company. So we produce all recycled products for polyester, polyamide, and spandex at the same time. And nice to see you today.
Thank you. All right, so let's dig into the ocean-bound. It's a fairly recent concept, and might be
Can
worth.
we stop on this one? Maybe, yeah.
Which one do you want?
This one is a good place to start.
No, let's start here. So, what's the situation? Why would we want to recycle ocean-bound plastics?
Yeah, it's been heavily mediatized. Everybody likes the idea of a clean beach, but when you see on TikTok feed these giant garbage patches of plastic floating in the ocean, it really turns your stomach over. And there's been a lot of initiatives to try and improve that. This is some academic research, which is attempts to estimate the amount of plastic that's going into oceans around the world. So the blue bars are what we can call macroplastics, so like bottles, for example, and the green bars are what's called primary microplastics, so there are already microplastics or fibers, for example, or road dust and so forth that gets into the ocean as a microplastic. A lot of the macroplastic, in fact, gets broken down with time from sunlight and from seawater and becomes later on fragmented microplastics. But this is comparing macroplastics with microplastics. So there's about it's really about plus or minus 50%. If you look at the studies, 8 million tons of macroplastic going into the ocean every year, and about 1.5 million tons of microplastics. And they are mainly coming from lesser developed countries which do not have organized municipal waste collection. Some studies showed that there are 10 major rivers are responsible for about 80% of the plastic in the oceans. Some later studies have said it's more rivers than that. But anyway, at maximum 1% of rivers are bringing plastic into the oceans. For example, the Mediterranean. 40% of the plastic pollution in the Mediterranean Sea comes out of the Nile River. You know, the Nile River is several hundred kilometers long, and all along the banks you have communities who are living in areas where they don't have organized municipal waste collection. Plastic ends up in the Nile and then afterwards in the Mediterranean Sea. So the idea behind ocean-bound plastic is to stop at the beginning, to turn off the tap, as we say. That's the...
Yeah, there we go.
So this is the principle behind ocean plastic. Imagine you come home to your kitchen and you find that the tap has been left on and the sink is overflowing and there's water flooding all over the floor. What is the first thing that you do? Do you get a mop and a bucket and start, collecting it, or do you switch off the tap? So, yes, the first thing you do is switch off the tap, and that is the principle behind ocean-bound plastic, is to switch off the tap, because it's much easier, in fact, to switch off the tap. You're collecting plastic, which is more accessible. You're collecting plastic, which is more valuable. And switching off the tap is a much more, somehow, realistic target to prevent thousands of tons of plastic entering the oceans than trying to pick it up off the floor, because this kitchen is already knee-deep in water or plastic or something like that. That doesn't mean, of course, that there's anything wrong with taking plastic out of the ocean. I mean, we would encourage every effort that works on that as well. But the ocean-bound part is a very specific part about switching off the tap.
So there's this slide here. There's that 50-kilometer perimeter with which is considered ocean-bound.
What is ocean-bound? Yeah, there is no, as far as I'm aware, there's no real official definition. There is a consensus which is starting to form. This is coming from an academic paper from Jambeck, which is very often cited, but there are other views on what ocean-bound plastic is, but these are the key four things that they identify. So it's something that's within 50 kilometers of the oceans or a coastline or a major waterway, so it's something that risks to get into waterways. It needs to be coming from a country or region that lacks a waste management infrastructure or collection incentives to collect plastic. So 50 miles from the coast here in Germany, the plastic is simply not going to end up in the ocean because there's a deposit scheme and the plastic is collected. But if you are in Indonesia, it's a completely different story. Or I was recently in Mumbai, 20 million population, 40% are living in slums. So you have 9 million people there with no collection of municipal waste. And the garbage, when the rains come, the garbage just goes straight out into the sea. The third point is about infrastructure being overwhelmed by growth or tourism. These are often fast growth areas, which is also moving faster than the infrastructure. And a significant risk to wildlife if plastic contaminates the ecosystem. So plastic which reaches these criteria can be considered ocean plastic, and maybe as time goes on, the definition will become more formalized.
Okay, all right, thank you for that. So this is an interesting intro to how plastic waste reaches the oceans. Now, what can we do once the plastics, and if we stick to maybe the bottles, I'll ask you, François Devy, what's the situation there? How do you collect the ocean plastics? And how can they be reused? Are they in any condition that can be reused? What's the situation there?
Yeah, I think it's important to understand that we are sharing the same vision, which is keeping the ocean clean. We have different missions. So as you said, I think there is, I think 80% or 70% of the plastic that is going to the ocean is coming from land, obviously, and the rest is coming from fishery. So obviously you have got the three options on the table. So you need to stop the tap at the beginning. On the fishery, you need to have people like Hyosung collecting the fishing nets. And then at the end,
Closer.
and then at the end, basically, there's still plastic into the water. So this plastic is degraded and transforming itself into microplastic. So you will always have this picture of the big Pacific garbage patch, which is seems to be quite huge, but it's only 1 or 2% of the plastic that is in the ocean. The rest is sinking, going into the bottom of the ocean, with right now unknown, let's say, yet clearly scientific proof that it's a big issue, a big ticking bomb that we have in front of us. So obviously we have a lot of animals being killed by this type of stuff. It has also some impact on our health. But this plastic, needs to be removed. So we are removing them with local communities, whether it's fishermen, on the Nile, by the way, or on the seas in the Mediterranean Sea. It's degraded plastic, so it's not easy to recycle, especially if you do a mechanical recycling. So we are very upfront about this. We are integrating it into the yarn that we are doing in Europe and Latin America. As it is degraded, as it is mechanical recycling, for now, it can only be integrated at 10% into the yarn. So it's very important that people understand that this plastic is really under degradation process and it needs to be... I mean,
you can't. If you put more than 10%, then you don't get a high quality yarn, I suppose.
Exactly. And you all know that obviously in terms of quality, you need a qualitative yarn and fabric in order to be good garments afterwards.
So with the stuff that cannot be recycled, what do you do with that? What's the situation?
So that's important as well. In the sea, you obviously to get 10 tons yarn, you need to collect almost 40 tons of different plastics. So in plastic in the sea, you've got PET, polypropylene, HDP. You've got a variety of plastics. Some of them can be recycled, even if it's degraded. Okay, some of them cannot be recycled, like polystyrene, PVC, etc. So we are trying to give to the local economy, as local economies and communities there, a holistic way to get a solution for all the plastics. So PET is being recycled right now mechanically. It will be done chemically in the next couple of months. We are using also the polypropylene to recycle and to use for other parts of the chain. You can then be integrated into the car, into different parts of the car, like bumpers, into the instrument panel. So we're trying to work with the local communities so that the job that they are doing is really retributed across all the values of the plastics.
Thank you. David, Kwon, can you tell us about Hyosung's journey into recycling fishing nets? That's into nylon. We're not talking about polyester that much, right? Let me move forward here.
Yeah, we produce both recycled polyester from ocean-bound plastic as well.
Yeah.
Companies like Seaqual, François, they collect us high-quality PET bottles, and all we can do is produce with the high-quality yarn. That's our area. So we have both ocean-bound plastic recycled products, and then we have just a regular, normal mechanical recycled polyester. And in terms of nylon, actually, we were the one of the first to start off the fishing net business back in 2007. It was, At that time, demand and needs for the fishing nets or even recycled was not really high.
No.
Why bother?
Demand wasn't there.
Why do we need recycled fiber in our clothing? It's not a good idea. So we started off in our lab. We commercialized it. We made it into bulk production, but nobody wants it.
The attitudes towards recycled content have really changed in the past 5 to 10 years. So it's no longer considered a downgraded product. Now it's a need almost, right?
Now it's like a need. It's like a regular product. We consider it as a regular. So we started again, starting from 2015 around. Yeah. So up to now, yeah, keep on expanding the capacity. What we do is, I mean, we don't collect the fishing net ourselves, obviously, but we get people, fishermen, to collect the fishing nets. We call it discarded fishing nets. It can be from the sea, it can be from the ocean, it can be from the beach. And what we do is we chop down the fishing nets, and then we separate the nylon part because it has
Right.
PE, PP, all kinds of other polymers inside. Yep.
On this slide, yeah, it's only 60% of the fishing net is nylon then.
Yeah. So out of about 100 kilograms of fishing net, we can collect around 47 kilograms of nylon. Yeah, and that can make into the garments that we are making. Yeah. So we can say that we're contributing to the the ocean, and customers are asking us about the quality of the fishing net recycle because they think the yarn should be green and dirty.
Oh my God.
Yeah, and the garment, doesn't it smell like fish? We get all kinds. But what we do is it's chemical recycling. We take out the lactam, which is the main source of nylon. We just take out the source chemically, and then we remake into nylon. So the quality is perfectly same as the virgin
Right.
nylon. So
It's nylon 6?
it's
then?
nylon 6.
Okay.
Yes. Yeah. So this is the how it shows how the process works. Yeah. We collect, we chemically recycle it, recover the CPL, and we recreate as a yarn. Yeah, it's simple.
Right.
Yeah.
Okay. Thank you. So one thing that I find the most compelling in this ocean plastic or fibers and materials made from ocean plastics is the consumer message, in the sense that we all love to go to the beach. We all hate to see garbage on the beach, even in the water is probably worse. So is that a compelling message? And then when we're talking about ocean bound, how do you get that message across? Do consumers understand what we're talking about? Who wants to?
Maybe you could show that.
Yeah, you have a slide on consumer attitudes. Here we go.
Yeah, this was a study made a few years ago with more than 1,000 people asking their consumer perceptions towards ocean plastic or marine litter. And maybe not surprisingly, in almost every category, 4 out of 5, so let's say 80% of people or more were seeing that they saw ocean plastic as a real problem. Question number 3, I think, is interesting. It's seen as something which is a present threat. I think for a lot of consumers, sustainability is about saving the environment for our children or for our grandchildren. It's a long way away. But if you look at those photos of ocean plastic in the sea, that's something you just feel motivated to do something about it, and that should be stopped, and something has to be done. So from a marketing point of view, it's an argument which is much more powerful, and I think connects directly to consumers in a way that other sustainability initiatives, although they might be, of course, very valuable, but somehow don't connect that immediately with consumers.
Is there also the issue that in this industry we've been relying on polyester recycled from beverage bottles, but that are collected and cleaned and processed in industrial scales, whereas here we're talking about informal communities picking up waste around their beaches, bringing them to. It's a whole other story. We're talking about.
There's a whole social aspect to it as well.
Yeah.
If you have the plastic bank slide, that maybe.
Whoops. Let me go back.
We have 2 partners, POP, Prevented Ocean Plastic, and the other one is Plastic Bank here. And their mission is as much social as it is environmental. They describe their own description of Plastic Bank is that it's the world's largest chain of stores dedicated to the ultra poor. So everything that is available in the store can be purchased using plastic garbage.
Oh, wow.
So you can buy medical insurance, you can buy school tuition, you can buy cell phone minutes, you can buy basics like cooking oil or rice or clean water. All of these things are available in the stores to be purchased with plastic garbage. So they really have provide a social income to some of the poorest people in the world, doing something that they hadn't really thought of before, which is collecting plastic and preventing it from polluting their beaches.
Interesting.
And they go a long way because everyone is registered, so you have to be screened, you need an ID, and then they have like a blockchain system. IBM invented a blockchain system so that every transaction is recorded. And the whole, when we get a container of flake, we know basically we can track down, which beach pretty much it was.
Yeah, some of these are GPS tracked. Yeah.
And this kind of transparency and measuring is really important, I think, to avoid, that there is child labor or forced labor or things like
fraud,
that from what is a largely informal sector of collection.
Thank you. I want to go back to François Devy because the first product developed with Seaqual was mostly polyester, but you're also looking into nylon, right?
Well, in fact, what I said at the beginning, we try to give an holistic solution for the local community. So as in the sea, you encounter a lot of plastics. If you name the polyester, the polyamide 6, and the PP, that are the three main ones that can be recycled, we are trying to offer through our R&D and factories the solution for those ones, whether it's in textile, with all the various sectors we can work in, whether it's textile, automotive, fashion, etc., or in the injection molding industry as well. So there's a way to provide them with, let's say, more volume and more, let's say, retribution, which is indeed what you said. I mean, at the end, the idea is that in our case, I suppose the three of us, we have a fully ESG package out of the shelves. No? It's obviously environmental friendly because we're removing the plastic and preventing the microplastic. There is the social part, where really we enter into the education, into the more retribution for those people that are removing our contamination, and then the governance, as you discussed, the chain of custody, the blockchain, so that you have the full traceability almost end to end. So I think it's very important in terms of brands that they understand that there is a huge level, additional level layer of storytelling into the equation. I think the ocean is a moving item, obviously. It's representing, I think, 30% of the carbon trap. 50% of the oxygen we are breathing, 1/3 of the food that the world is eating. So, I mean, we need to take care of it.
That's true, yeah. David Kwon, can you tell us about certification at Hyosung? Let me try and move to the slide that covers that.
It's next, yeah.
Does it also have like GPS tracking or not?
So the certifications that we need is mostly two. It's called GRS. It stands for Global Recycle Standard. RCS is Recycled Claimed Standard. So RCS is under sort of GRS. So can you move on to the next page, please?
Yes.
Next.
There we go. Last one. Sorry.
So to prove that the yarn is recycled, we need to have these sort of certification. First one is GRS. It says, it proves that the yarn is coming from discarded fishing nets, or the yarn is coming from ocean-bound plastic PET bottles. It also shows that the yarn is coming from our factory's own waste. So GRS certification is the #1 certification that all the yarn makers must need. And TC it stands for Transaction Certificate. It actually tracks down all the way from the yarn and to the end garment. So when the yarn moves on to the fabric, you need a TC. And if the fabric moves on to the garment, it also needs a TC. So it's the most important transaction certificate. So GRS and TC, we need them both. to prove that
Yeah.
the product is certified as recycled.
François, you mentioned a minute ago that the PET plastics that are collected are mechanically recycled. Now, you're also going to chemically recycle them? And then, if so, why? Do you get a better raw material or not?
There's plenty of explanation for that. Obviously, the fact that you can absorb more degraded plastics because you're coming back to the monomer. So, I mean, in the ocean, the bottles can be very, very degraded, and even for mechanical recycling, in our case, we cannot use them. So, going to the chemical recycling will absorb more plastic. We can also absorb the colors. In mechanically recycled, we were using only the transparent one and the light blue. So there is the idea of giving more tools as well to the local communities to absorb, to give a second life to those plastic. And then obviously, as any people in the textile industry will understand, the spinning operation is not a really good friend to the mechanical recycling because obviously you've got a lot of waste. So going to the chemical, you're going to almost a virgin monomer.
Quality, yeah. So it means you can take in more, I guess, and then get more out of it.
That's the idea, obviously,
Okay.
and then to have a better performance in terms of spinning, obviously.
Okay. I had a question for David Bayliss. Because you touched on that topic earlier. When considering ocean pollution, what should we be more concerned by? The abandoned plastics or plastic debris on the beach, or the microplastics that will be coming out of them?
Maybe I mean I think the histogram shows the answer to me. 8 million tons of microplastic and 1.5 million tons of microplastic, approximately, because nobody really measures that. Yeah, I mean they look at the average household disposal in different countries and multiply it by the population, and they try to work out. So it's not very precise, but there's no question that macroplastic is several times higher than what is going in with microplastic.
Yeah. And then it's easier to pick up
might be easier to stop, exactly, yeah, where microplastics are so tiny that they're difficult even to detect, and they're, of course, very pervasive. So
Right.
they're both problems, but in terms of size, yeah, macro is more significant, but micro is also a problem, certainly. Yes.
Yeah. All right. I have a question also for David Kwon here. What in the regen nylon, what is the proportion of recycled content? Is it 100% fishing net or not?
It is. We have different kinds of products. We have 50% virgin and 50% post-consumer for a better price level for customers.
Okay.
And then we have 100%. So we have two types.
Right. Yeah. Yeah, because we tend to forget that there are all these operations: the collecting, the cleaning, the chopping, the dissolving, do add extra steps. So these materials will be a little bit more expensive, I suppose.
Yes. Plastic Bank actually pays a premium to all the collectors on top
Right.
of the economic value of the plastic.
And David?
And
Yeah.
if it's for recycled nylon, we have one more process. We have polymerization takes place 2 times. So
Okay.
it's more work.
Right.
So it is quite not, I would say, reasonable price level
Okay.
for the recycled. Yeah.
Okay. And François, anything to say about the
It's clearly
matter
more
of-
expensive, but at some point it's our collective responsibility to solve the issue. So, I mean, if you cannot absorb a 20, 30% increase in price, then we have an issue.
Okay. I have one more question for you, and then we'll open the questions to the audience. If plastics spend too much time in salt water or under the sun, they're going to be degraded. The question is, how fresh does the debris have to be? And even for fishing nets, because you don't know how long they've spent in the water, do you? I mean,
No, and I mean it depends on the batch. I mean, obviously, as you can understand, it's quite changeable in every batch. So it's very difficult to understand what's the level of degradation. Obviously, at the recollection point where we are going, we see that obviously, I mean, if the plastic is staying for the last year on the beach or on the sea, I mean, yes, it will be very degraded. Again, it's why with the mechanical recycling, you can only put 10%,
Right.
and that's why the chemical recycling is probably key to absorb all the plastic.
Right, right. Do you agree, David Kwon, about the chemical recycling?
Yeah, chemical recycling. The difference between chemical and mechanical recycling is chemical recycling, we're just taking out the chemical. So even if the fishing net is dirty, it doesn't matter because we're just taking out the
You're going to
chemical.
filter out all the stuff you don't want.
And the purity level of the yarn must be more than 98%. If it's lower than that, we don't consider that a product.
Okay, yeah. And so then this speaks also, David Bayliss, to the importance of catching those bottles before they reach the ocean.
Yeah, no question.
Right.
The ocean-bound plastic is much easier to recycle and of higher value.
Right.
A plastic bag, in fact, they recycle everything that they collect, but there's a kind of gradation, and a clean, transparent bottle, those are the diamonds amongst all the rest of the trash, and then there's a lot of other stuff as well, which is harder to find homes for.
Right. And so do you have to can you only take, since you're mechanically recycling these, you have to take like the top of the cream of the crop, or?
It depends on the application. So, for example, if you want to make a nice white polyester, you need to take transparent bottles, which is the cream of the crop, as you said. But there's also a big demand for black polyester as well. That goes into the headliners of cars and things like that. And here you can use different colors.
Right. Okay.
And that gives, but in the end, you need a certain level of purity. You can also, for filament, for example, I mean, if we're talking about staple fiber, then we're talking about mechanical recycling, which is going directly into extrusion. In the case of filament, it's more often re-extruded. It goes through like a fine micron filtration, and then you can use different grades to some extent to feed into a filament production. Okay. But for sure, underneath the cream, there are other levels which have other end-use markets with less value.
Right. Okay. All right. Great. Thank you for that. So let's see. Anyone in the audience have questions for our speakers today?
That means we did a good job and we explained everything.
I was actually wondering what the audience thought about the concept of ocean-bound versus ocean-found, and which message is more compelling, or which one is more realistic, because fishing out all that junk is probably just beyond what we can do. I don't know. Any thoughts from our members of the audience? Oh, no. All right. Well, in that case, thank you so much for coming.
Thank you, Sophie.
Thank you.
Thank you.
Thank you.
And keep on the good work, I guess.
Thank you, Sophie. Wonderful to have you on stage. Have you learned something? Or were you aware of all the
No,
answers
I didn't
from
know
the
about the
panel?
chemical recycling. Yeah, I learned things. Always learn things when you ask questions.
So, thank you.
Thank you, Kim.